Hey everybody, welcome to the first talk of the developer track. If you want the integrations track where Bobby is talking about Google Summer of Code, you're in the wrong place. Here we've got Rohit today, and Rohit's talking about MBX, which is a local CICD for CloudStack. So everybody please give Rohit a warm virtual round of applause. Over to you, Rohit.
Thank you, Giles, and thank you everyone for your time to attend this talk. My talk is about MBX. It's a new tool that helps you set up a local CI/CD system for CloudStack. Um, I've been working on CloudStack for more than 9 years, currently working as the principal engineer at ShapeBlue, where I lead the software engineering function for my team. Over the years, I've authored several flagship features and tools. These days, as a side project, I'm working on the ARM64 Raspberry Pi port for CloudStack. And on the bottom right side, you can see my cats, Ashley and Gracie. So I love cats in programming. Okay, what is the topic for today? So we'll just go through what MBX is, what led to MBX, briefly look into the design and implementation, and we'll try and spend most of the time towards the demo of MBX. So MBX is a CI/CD tool. It's a tool that can allow you to build CloudStack packages, can help you deploy a dev or QA environment, and help you run smoke tests. So the question is why, right? Why do we need a tool like MBX? We've got Travis, we have Trillian and Blue Orangutan, and that's all we currently need. So why another tools? There is a story, but before we get to the story, let's just briefly look into the history. So a list of CI/CD tools have come up in the community over the years. It started with Citrix's the build verification tool, BVT. Later on, this is circa 2012, we saw a new tool called DevCloud, which used to run on VirtualBox, can run Zen Server. And later on, saw the KVM variant of DevCloud, which runs on KVM. When the project was donated to ASF and eventually we got moved to GitHub, we saw integration to Jenkins and Travis, which would usually check a pull request or a Git tag against simulator. And later on, which I say is a third gen tool, is Trillian and Blue Orangutan, which created a general purpose CI/CD system, which runs on vSphere and pretty much can run any hypervisor, which is what we currently use. And around the same time, as sort of an iteration of DevCloud, came Monkeybox, which ran on KVM, can effectively run anything, but was limited to just KVM. So before we jump into the story, let's also try and understand how people do dev and QA in the community. So most of the developers will use Maven and Simulator or their custom setup to work on their fixes, features, bug fixes, and improvement. And typical dev workflow would be to write and execute a unit test. And if they want to write a functional test, they'll write Marvin test. And they can use either DevCloud or Monkeybox or their own DIY setup to execute those Marvin tests. QA, on the other hand, would either build packages. Building packages inherently runs the unit tests. And in order to run Marvin tests, we got either Travis, which integrates with GitHub pull requests and runs tests against simulator. We also have Blue Orangutan, which is a GitHub bot that integrates with Jenkins and Trillian on the backend side, which can again run smoke tests against GitHub pull requests, tags, and whatnot. That's largely what we have got in the community. So what is the story? So ShapeBlue has been running Trillian over the years, and it has happened a couple of times where one time we lost the lab because of some hardware malfunction. And in order to recover the lab, we had to spend a lot of time. And another thing happened early this quarter this year, which is we wanted to migrate to a new Sophia lab, and the London lab had to be shut off. And while we were working on this, in order to support many different hypervisor, Trillian is a complex project to set up. It requires a lot of thinking and design and implementation of hardware, networking, and whatnot. While this was ongoing in Q1 2021, we were discussing, should we have a backup plan? And within the leadership, we decided, let's do a secret backup plan. And the idea is that let's hope we never have to use it. And it turned out we didn't have to use it, which is great. But we said, let's just do a simple POC that doesn't require a lot of effort. So with me as sort of the developer of the tool and Vladi, who kind of helped tested this tool, we said, let's put 2-3 weeks, not more than that, and see if we can come up with a backup plan. So that's what led to the development of MBX. In terms of the design and implementation goals, the first thing we did was we had a secret meeting between Vlad and Bobby, who lead the QA function at Shape Blue, to say, what are the goals of this backup plan? Like, what is the bare minimum that you require so that you're not blocked on your day-to-day work? And first, I think the main requirement was it shouldn't require a lot of effort to set up. Setting up Trillian can take a couple of weeks, maybe months. And setting up a new backup tool shouldn't take a lot of effort. We want it to be automated if possible. The other thing is that we also want to be able to build CloudStack packages, because if there's a CloudStack feature or bug fix, the first thing you want to do is build packages and then after QA those packages. And they wanted some kind of a test matrix environment, which is what Blue Rangitan sort of gives you on GitHub pull request, which is essentially the CentOS 7 management server with the 3 different type of hypervisors that we support, namely KVM, VMware, and Zen server. And they also said that NFS storage is okay in advanced zone. And they also gave a requirement that it will be good if you can run it on a community hardware, i.e. your own laptop or a desktop, and maybe have VPN access so that your colleagues can also, have access to those environments as a sort of backup. So that's what led to MBX, these what I'm calling the 4th gen CICD tool, which kind of learns and iterates over the previous tools and simplifies the implementation in a way where it allows you to build CloudStack packages. With it, you can launch a dev environment. A typical dev environment will have maybe 1 or 2 hypervisor hosts, and you would write code in an IDE, you would run MySQL and NFS on your host or your workstation or your laptop. And only the hypervisor is the entity that runs inside a nested VM. For QA, you can launch a QA environment, which by default, the convention is to deploy 2 hypervisor hosts and 1 management server host. You can also run the smoke test through the management server host. You would want some kind of automation and tooling to be able to run those Marvin tests, gather report, and see whether it worked or failed. It currently supports KVM, VMware, and Zen server, the 3 hypervisor based on the requirements, and can support NFS and local storage. It does automatic VLAN and IP allocation management. That means if you can run multiple MBX environments, so like a combination of multiple environments on the single laptop or host or your own desktop. The typical workflow is also supported where both dev and QA can deploy an environment, launch a zone, and then perform other operations like starting the whole environment, destroying it, stopping it, or running smoke tests. So what is not MBX? So MBX is not meant to replace any of the existing tools. It started as a backup/secret project, but it can now be seen as a supplementary tool for different use cases. So for example, somebody wanting a quick dev and QA environment, somebody trying to create a distributed CI/CD for their use case and their infrastructure where they want speed over complexity. Or maybe, let's say for our case, which is to serve as a backup in the event of a lab failure when we don't have a lab for our colleagues. Who can use it, right? So pretty much anyone starting out with CloudStack, a student, a junior developer, a user who just wants to try CloudStack. Try CloudStack, not using simulator, but using real hypervisor, but in a nested fashion. Any developer in QA who wants a dev test environment, anyone who's wanting to create a CI/CD or dev test environment for their ASIS integration and testing. Surprisingly, this came up with another organization who were building some feature on top of CloudStack, and they needed a quick CI/CD system to develop their integration where they were using MBX. So in summary, anyone who is looking to create a CI/CD system, a dev test environment out of the box before they go and create something complex, maybe on bare metal or maybe set up Trillian. So how does MBX work? We'll try to wrap up the slides very quickly, so focus more on the demo. But very briefly, we'll just quickly look at that. How it works is by creating, first of all, a host-only network, which is a virtual NATed network in the RFC 1918 space. Then it uses hypervisor templates, which are DHCP enabled to start nested environments. Underlying it uses KVM hypervisor and uses NFS storage. It can also use Docker if anyone wants to build packages. Optionally, we do have OpenVPN support. So you can think of using MBX to start a VPN server, to which your colleagues and other people connect to. It is quite fast and automated. A setup can take anywhere from 5 minutes to 30 minutes. It depends on the speed because it downloads a lot of templates. And it's quite hackable. It's about less than, I think, 1,000 lines of code. So people can customize MBX to suit their needs. This slide describes very briefly the network setup of MBX. In this case, we can see that you have a host, maybe your desktop or a workstation or a laptop, which is connected to external network, maybe internet. And on it has a local host-only network in the RFC 1918 space. In this specific example, we can see 172.20.01/16, which is then used to create and assign IP addresses to Monkeybox VMs or the MBX VMs. On the right side, we can see how a nested environment plugs their NICs inside a KVM box, which again runs as a virtual machine on the KVM host. So how do we get MBX? It's simple. Go to the GitHub repository. The only requirements are you need to have an x86 machine with at least 16 gigs of RAM, 32 gigs of RAM is preferred, 4 cores is preferred. The supported host OS is Ubuntu 20.04, which is preferred, but now it also supports CentOS 7. For storage, we require NFS, and for hypervisor, we require KVM and KMO. So let's just directly jump into the demo. So let's first look into the GitHub repository. So how do we start? So it starts with cloning the let's just scroll here. It starts with cloning this repository. There is the README page, which describes how do you set up and install MBX. If you look at compatibility matrix, you can see the host OS is Ubuntu 20.04 or CentOS 7, the amount of RAM and CPU required, the supported hypervisor templates, and the versions of CloudStack we have tested so far MBX with. In terms of installation, we start with NFS setup, which I've already done to speed up the demo. And I've set up KVM also. So I've got my Word manager here for demo. And that's pretty much it. To get started, you have to create /export directory, which is also serves as your NFS export. Then you can export, after cloning MBX repository, you can put it in the path so that you can call MBX. So let me just show you this. So basically, if I run MBX, I can see these are the various commands it can support, like initialize, package, list, deploy, launch, so on and so forth. The first thing we do is whenever you install or upgrade MBX is to run MBX init. What MBX init does is it creates the host-only network, which I'll just show you very quickly. So it creates this network called MonkeyNet in the RFC 1918 space, specifically 172.20.00/16, and it's a NATed network. The next thing it does is MBX init will also initialize a couple of files. It will download the templates. So if you just go to export Monkeybox and go to templates, you can see a bunch of QCOW2 templates, which it has downloaded from the internet. So once MBX init is done, what can you do next? So for that, we can probably switch to our demo. So let's start with MBX package. So we may not have a lot of time, but MBX package essentially takes in the GitHub repository URL, the branch or git tag, and the package you want to build. So I'll just launch this, but we won't wait for it to finish. So essentially, this will first try and download the repository at a temp path, and then it will kick Docker to run packaging. So while this happens, let's try and figure out other commands. So we'll just open another terminal and we can look into MBX list. So prior to the environment, to this talk, I've created a few environments. So if I do MBX list, you can see various environments, their IP addresses, list of templates which are available. So let me just walk through how do you interpret and read through this list. So MBX list gives you a list of existing Monkeybox or MBX environments, and they have a name here at the top. And every environment has one management server and 2 hypervisor hosts. They have their IPs here, and in some cases, they may have their URLs here. So this, for example, is the URL of the management server. So if I click on this, and I have the management server UI open here, and I can log in with the default username and password, which is admin and password, and I'm already in. So this environment is running here. So let's just open Word Manager so we can see. So this is QA1 CS416. And these are the 3 VMs, which are the nested VMs. This one runs the management server, and the other 2 hypervisors are the KVM hosts. And by double right clicking, copying, or just opening this URL, I can go through the UI, explore my environment. So for example, a very typical thing to see is my system VMs are running. So I can see the consoles, and consoles are running. So they're all running on this workstation I've got. And just to demonstrate that it's a functional environment, I've deployed a small VM also. We can see the console of that VM. Maybe try to log into the VM. If I got the password wrong, maybe. Right, and then maybe we can ping google.com. So this just demonstrates what is the end product of, let's say, an MBX environment. So how does it work? So it starts with the MBX deploy command and then launch command. Let's try this. So MBX deploy creates a QA environment with 2 monkeybox VMs and creates a config file also. So the deployment step actually split into 2 phases. The first one is the deploy command, which simply creates an environment, and launch command will actually deploy the zone. So let's try this. So I can say mbx deploy -h to see what are the parameters I should pass. It says mbx deploy name of the environment. So I'll just say mbx demo. It says the management server template. So when we do mbx list, at the bottom, you'll see following MBX templates are available. So these are the templates which I can specify in that command. So currently only the CentOS 7 template is supported as the management server. So I can specify CentOS 7 to be used as my management server template. Then I have liberty of specifying any of these templates. So let's say if I need a XCP-ng environment or Zen server environment or KVM environment, I can simply copy that, paste that. And this command will basically deploy a MBX environment with the CentOS 7 as the management server and the KVM, 2 KVM hosts. As an optional parameter, I can also specify the repository URL. So for purpose of this demo, what I've done is I've created a repository clone of 416 RC3. And what we can do is we can simply give the repository URL that I want to deploy. So this is your packages repository that you want to use to deploy the environment. Click on enter and let's see what happens. First thing it does is it copies and clones and creates these VMs. So we can see created host 1, created management 1, and quite quickly we'll see host 2. So the first step MBX does is it uses these templates. These are the templates to create these virtual machines. And once they are cloned, then it starts them up. It also creates the primary and secondary storage folders, and it will seed the system in template and whatnot. So while this happens, let's actually go and look at some other command. So this will take anywhere from 5 minutes to 15 minutes to set up. And we will go through the log after some activity sort of happens here. So we'll do mbx list here. And now we got 4 monkeybox environments. The first one is already deployed in launch. The second one is a Zen server, or sorry, the XCP environment. And the third one is a VMware environment. So let's just open them one by one in the browser just to see, just to prove to you that they're empty, they are not deployed. So we'll first go into the XCP environment. That's this one. And we can see that it's just CloudStack installed. If I click on infrastructure, you can see there's nothing sort of installed here. So let's try and deploy, launch an environment. So we'll say mbx launch and simply give the name of the environment. What this will do is it will set up a Marvin config file, make sure Marvin is installed on the management server, and then deploy a zone using a Marvin config file. The same Marvin config file is then again used or can be used to run tests. So while this is happening, which is this command is now trying to install Marvin, Once this succeeds, it will then try and launch a zone. So I've already launched a zone for the first environment, that's QA1. So you can pretty much see the output. It installs the dependencies, and then it uses the deploy command to deploy the data center. There's one more thing we can test while things are happening in parallel. We can use MBX SSH to SSH into environments. So you can say MBX list. Let's go into the management server one of QA1 environment, which is already launched. Here, if I go to the Marvin directory, here I can see there's a smoke test.sh file. We can also, let's just open the environment in parallel. So we can also open this thing in the browser just to see what's happening. So this is our QA1 environment, which has the demo VM already running. And in it, I can run smoke test by simply running the smoke test.sh file. So we can see smoke tests have started running for test accounts.py, and we see tests are already passing against these environments. If we tinker around, we can see accounts being created by the smoke test. We can see maybe a template which is created by the smoke test. And if we head over here, see this test VM is created by the smoke test. So this is to just demonstrate that smoke test can also run out of the box. Let's go back to the XCP environment. So this is our XCP environment, and there were no zones, nothing here. So if I refresh now, I should see some activity. Have I got the right? Okay, this is the XCP environment, and if I open here, you can see the zone is being deployed right now. 2 zones have been added. So these 2 XCP hosts have been added. Once it gets connected, we'll see the system VM sort of launch. As a last example, I have the VMware environment set up here also, which is generally the most complex to work out. And here I can open the management server URL, which here we see there's no, the zone is not deployed. And we also see another machine called VC, which is for vCenter. So I can open the vCenter console also. I think prior to the demo, I've already logged into the vCenter console, so we can see vCenter also working. This sort of demonstrates the feasibility of using MBX as a quick tool to deploy Zen server, KVM, and VMware environment on your host. Launch smoke test, use the MBX SSH command to get into the machines without having the need to remember the username or password. So like I can do MBX SSH. Let's go into one of the XCPNG hosts. I can like do this, and I'm inside the XCPNG host. And if you scroll through the other commands, we got stop, start, and destroy. So as a last sort of demo example, I'll try to destroy, sorry, MBX list. I'll try and destroy one of the environments. So let's destroy the first environment. And while we do this, let's have the word manager open. So as soon as I run this destroy command, you'll see these VMs sort of gone. So it's very quick. It takes roughly less than a minute to destroy an environment, anywhere from 10 to 30 minutes to deploy a environment, depending on whether it's VMware, KVM, or Zen server. And that's pretty much the demo. Right, so our QA4 environment is also deployed. So we can see this is the environment which used, so let's see this. So this is the MBX demo environment which uses 416 RC3. You can open the URL in the browser to see the management server is actually running. And we had the others, XCP environment also, where it's still trying to deploy the zone. So with that, I think, and smoke tests are running on QA1, which will not be accessible now that it is destroyed. So with that, I think the demo sort of concludes. And just to talk very briefly about what is the future of this tool, which is the tool is very small and concise and effectively can support other hypervisors, including type 2 hypervisors such as VMware Fusion, Workstation, or VirtualBox. It is possible to do multi-machine setups also. We can have a distributed community CICD system where multiple MBX boxes connect and share test specific task for a pull request for git tags and whatnot. And the next task is to have, aim for 100% smoke test pass. Right now, most of the tests do pass on MBX, but some of them don't pass due to environment specific configuration. And in the pipeline, we are thinking if we can aim for 100% smoke test pass, support EL8, and maybe Ubuntu as the MBX management server and KVM templates. So that's basically, we think, can be the future of MBX. With that, I would like to thank Giles. I'd like to thank my audience for your time for today, and to Ibet and our sponsors for this wonderful virtual conference. And let's do some quick Q&A if you have any questions.
Brilliant. Thank you, Rohit. Thank you very much. Not a huge number of questions coming through. Harry has asked, can we use this for testing CloudStack management server upgrades and hypervisor version upgrades?
Yeah, yes, this is doable, but it's not completely automated. So you can indeed deploy a CloudStack environment and simply do apt-get upgrade or update with 416 and above. So certainly CloudStack upgrades can be used. For hypervisor specific upgrades, we'll have to check how those upgrades are done. So it can be done manually, yes.
Brilliant. The other question is Rakesh has asked, can I run this on a virtual machine which is already running on CloudStack to set up a nested CloudStack setup, like CloudStack within a VM?
Yes, that's an interesting question, right? So you're trying to do inception inside inception inside inception. Funny enough, I tried to do that at 7 layers. That means running a VM inside a VM inside a VM, doing that 7 times. After the 7th time, it kind of failed. So I can certainly say that you can do it twice or maybe thrice. The only problem can be if there is any network glitch, storage issue on the underlying nested environment, then your upper workload, which is a nested VM inside a VM, can fail or can crash. So I've seen kernel panics out of curiosity when you do that. In the demo we saw today, it certainly was running on bare metal. And I think I've tested running MBX inside MBX while adding support for CentOS 7. So I can certainly say it works.
Cool. That's all the questions we've got. So everybody, please give Rohit a very warm virtual round of applause. Rohit, thank you very much. Really interesting stuff. Next talk on the developer track is Rudikesh talking about cloud native deployments with Terraform, Ansible, and Kubernetes. Over on the other track, we have got NTT talking about their use of CloudStack. So thanks again. Thank you, Rohit.
Thank you, everyone.